For many years, astronomers have observed one of the brightest and most enigmatic stars in the night sky, Betelgeuse, a red supergiant teetering on the edge of collapse. Scientists have long predicted its explosive end, but the exact timing remained a mystery until now. The James Webb Space Telescope, JWST, has captured what few dared to hope for, the precise moment Betelgeuse began its explosive transformation. This isn't merely another deep space discovery. It marks a once-in-a-lifetime cosmic event, the closest supernova humanity has ever recorded. What the Webb telescope observed has fundamentally altered our understanding of stellar death. Situated in the shoulder of the Orion constellation, Betelgeuse is no ordinary star. It's a red supergiant over 700 times the size of our Sun and approximately 20 times more massive. Scientists have known for decades that the star was unstable, showing signs through cycles of brightening and dimming. In 2019, its sudden and significant dimming sparked global speculation. Was this the beginning of the end? Was Betelgeuse about to go supernova? Now, with the unparalleled sensitivity of the James Webb telescope, that question has taken on new complexity. For the first time in history, we are witnessing in real time the unmistakable indicators of a star in the throes of collapse, massive energy emissions, shifting convection on its surface, and magnetic fields unraveling into chaos. Betelgeuse isn't merely dying, it's evolving into something new before our very eyes. The Webb telescope has been intently monitoring Betelgeuse for months, using its advanced infrared instruments to peer into stellar layers invisible to all previous telescopes. The data it has returned is astonishing. Gigantic convective cells, bubbles the size of Jupiter, are erupting on the star's surface. Hot gas is being hurled into space at incomprehensible speeds, and hidden in the light spectrum is the clear signature of a shockwave rippling through Betelgeuse's outer shell. For the first time, astronomers are directly observing the physics of a star tearing itself apart. This isn't a simulation. It's a real-time autopsy of a supernova taking place just 642 light-years from Earth. Unlike distant supernovae occurring in far-off galaxies, Betelgeuse is a near neighbor by cosmic standards. When it fully explodes, its light may outshine the full moon and even be visible in broad daylight. But its significance goes beyond spectacle. Its relative proximity offers scientists a rare, perhaps unrepeatable opportunity to examine the intricate details of stellar death. They can now analyze how a star's core collapses, how elements like carbon and oxygen are created in the crucible of a dying star, and how shockwaves sculpt the surrounding cosmic environment. What Webb has captured isn't just the end of a star's life. It's the very process that produces the elements essential for planets, ecosystems, and life itself. We are watching the raw mechanics of our cosmic origins unfold in reverse. Betelgeuse's explosion is more than a dramatic celestial event. It's a key that unlocks the inner workings of galaxy formation, planetary development, and the universal cycle of life and death. With Webb's cutting-edge tools, scientists can now construct unprecedented models of a star's final evolutionary stages. These observations may even allow us to identify early warning signs of future supernovae in other stars, possibly decades or centuries before they erupt. This moment isn't just about astronomy, it's a revelation. A rare moment in which humanity peered into the abyss of deep time and saw a flash of truth explode back at us. The collapse of Betelgeuse doesn't end with its visible explosion. Shockwaves from the event are spreading across light years, disturbing the interstellar medium surrounding the star. Webb has already detected high-energy particles racing outward, heating gas clouds, and reshaping the star's dusty outer halo. But there's more, a detectable gravitational shift. Even from 642 light-years away, the implosion of Betelgeuse's core may have generated gravitational waves, subtle ripples in space-time that scientists have only recently begun to observe. If confirmed, this would be the first time a visible supernova has been directly linked with gravitational wave data, a breakthrough that could revolutionize our understanding of how light, matter, and gravity interact on a cosmic scale. As Betelgeuse collapses, One of astronomy's great mysteries returns. What remains after such an explosion? A neutron star? A black hole? Or could it be something stranger? Webb's data indicates the collapse may be uneven. Magnetic field disturbances, voids in plasma, and a possible fallback scenario, where stellar material initially flung outward, fears pulled back into the core, suggest a complex chaotic end. Some astrophysicists are even speculating about the emergence of a transitional object, something that lies between a neutron star and a black hole. Such an entity has been theorized but never observed. If Webb has caught this phenomenon in progress, it may represent the first confirmed evidence of a new class of stellar remnants. Given Betelgeuse's proximity, many wonder, are we in danger? The short answer is no. Earth is too far to be affected directly by the explosion. However, the broader implications are more nuanced. The blast will unleash intense radiation, gamma rays, and expanding waves of electromagnetic energy. While not harmful to us, these forces could impact nearby star systems, alter interstellar dust clouds, and even affect how light travels through space to reach our telescopes. Webb is currently monitoring the speed and behavior of this radiation front, because while we are safe, the explosion may shift the optical dynamics of our galactic neighborhood, changing how we observe the universe itself. Betelgeuse is colossal, ancient, and immensely powerful, and yet it is dying. A reminder that even the most enduring lights in our sky are not eternal. What the Webb telescope has recorded is not just the death of a star, but a mirror reflecting our own impermanence. Everything that lives must eventually end. Yet in that ending, new elements are created, new stars are born, and new worlds may form from the remnants. This isn't annihilation, it's cosmic regeneration, and we are extraordinarily fortunate to witness it in real time. Among the wealth of data collected, Webb also made an unexpected discovery: unique variations in the composition of the expelled material. Betelgeuse's explosion is producing not only expected elements like carbon, oxygen, and iron, but also rare ones such as technetium and yttrium, elements that can only form under extreme stellar conditions. This is crucial because by analyzing the ratios of these elements, scientists can trace the journey of matter across the galaxy, from the core of dying stars to the dust that builds planets to the atoms that make up our bodies. Webb isn't just documenting a cosmic detonation, it is translating the chemical language of life's origins. Betelgeuse, in its final act, is telling a story that predates Earth itself. The star will never reclaim its place in Orion. In its absence will be an expanding cloud of incandescent gas and debris. But this is not the end. It's a legacy of knowledge, of elements, of perspective. It serves as a stark reminder that our own sun will one day meet a similar fate. Even the brightest stars have a final chapter, yet from their endings the building blocks of everything new are born. Without supernovae, there are no planets, no oceans, no life. And now, thanks to the James Webb Space Telescope, we can witness the entire cycle, from collapse to creation, unfold in the silence of deep space. Some 642 light-years from Earth, a star's life ended not in silence, but in a blinding, thunderous roar that has traveled across time to meet us. And thanks to the James Webb Space Telescope, we didn't just observe this cosmic finale, we comprehended it. We saw the signs, tracked the collapse, witnessed the explosion, not as myth nor metaphor, but as scientific truth. Betelgeuse didn't die in vain. In its final flare, it delivered answers to questions humanity has asked for millennia. Where do the elements come from? How do stars end? What awaits our own sun? In that fading red light, Webb has captured far more than a supernova. It has revealed our cosmic roots and a glimpse into what comes next. So we must now ask, what else is the universe preparing to unveil? And are we truly ready to see it?